Good afternoon to everybody on the call. My name is Michael Dimelow. I'm the Executive Chair of Zeetta Networks. Today I'm going to be talking about how to operate a multifunction private network. There's lots and lots of noise in the market today about private networks. Nearly all of the private networks deployed today are static. And actually the use cases that are emerging, that we're seeing deploying, principally driven in North America, are going to require those networks to be more dynamic. So today, my presentation really revolves around that idea of moving from static, over-dimensioned private networks into a more agile and more dynamic private network instance. Next slide, please. Thank you. So in this particular picture, I've picked a stadia where quite often people gather in their masses. We're seeing an emerging use case around mass interactive gaming and esports, neutral hosting, broadcasting, augmented reality. And when you get many people in one location, the importance of how you handle emergency situations increases, and that you need to instrument those environments more. And all of these individual components of the use case put stresses and strains on the private network and the need to assure and deliver slices to different, either whether it's people or it's machines, in terms of delivering end-to-end QoE and QoS. The benefits of applying a better operational overview of those networks is that we get a better consumer experience. And it's easier to manage and operate those networks. We're able to partition and scale those networks better. And then ultimately apply a little bit of AI to assure performance. Next slide, please. So Zeetta Networks was founded in 2015. It was a spin out from the University of Bristol in the communications department. We led a very large, about a 10 million euro project in the UK called 5G Encode. It was a global consortium of OEMs and end customers to validate different use cases around 5G. One of the use cases was around using augmented reality VR to do training and deliver near real-time communications to those people using those devices. What we've been looking for ever since is how do you scale up that type of application, and mass interaction and esports is an area where we're going to see a shift. When we get 10 or 15,000 people in the stadia all playing competitively, the stress and strains on those networks escalates. And as we shift screen-based interaction to head-up displays and AR, VR, then there's a new dynamic that will appear in that use case. But ultimately, we've done this before, and now we're moving into a more commercial domain, and that's the nature of this particular presentation. Next slide, please. There's various alignment points. I won't go into detail on each one. The one that probably is interesting to this assembled group is how do you apply AI to provision and create that dynamic slice management? That's the one that's probably the one that's on the top of everybody's minds. How do you reduce over-dimensioning of private networks and yet deliver the same quality of experience for the application and QoS end-to-end? And that's the kind of core of our value proposition to CELTIC-NEXT and to the community that we're looking to build around this proposition. Next slide, please. I've touched on nearly all of the points in here, whether we're instrumenting a stadia, but fundamentally it's how do you get many people into the same location and deliver an experience that they would get when perhaps in their own bedrooms, for example. And US is leading the way, and to some degree Europe, in esports, mass gathering esports initiatives. And these will create new demands on network operators, new demands on private networks, and will require a more adaptive and dynamic traffic management proposition. Next slide, please. The state of the art, I think, is all well known. I've touched on most of it on the left. There are opportunities for innovation in automating configuration, partitioning connectivity, creating layers of virtual networks and virtual slices, dynamically adapting that network to make it more scalable. And the bits, there's some interesting little emerging opportunities around this use case is, once you've got people into an event space and they're playing competitive gaming, believe it or not, people want to then broadcast it to the world. And so rather than connecting that broadcast equipment up using proprietary radio and fiber optic, the question that's being asked among some of the leading broadcast equipment OEMs is, should we use 5G for that purpose? So not only using 5G to enable the interactive gaming, you're also using 5G then to broadcast. And again, this creates more tension on scarce resources. Applying a little AI to assure and potentially enabling neutral hosting for many operators to operate in that venue as well. Next slide, please. So outcomes, we're trying to create a performance and reliability blueprint for this type of mass interaction, a working neutral hosting environment, and proving out 5G for this kind of mass entertainment use case. It's all about enabling trust in network automation, reducing the cost to deliver that proposition in a multi-tenanted environment, and ultimately applying a little bit of AI to bring some intelligence to how do you manage that traffic when it's so dynamic. We expect the project to last 36 months. Next slide, please. And we've identified some partners in the UK, Ireland and Canada, but we're open to others in other markets, particularly RAN vendors and carrier service providers. So we're open to those and potentially IoT partners for instrumenting those environments. Next slide, please. So I'd like to thank you for your attention today. My name is Michael Dimelow. We're bringing an operating multifunction mobile private network proposition to this environment, and we've identified some international partners, and as I mentioned in my notes, we're looking for operators and RAN vendors that can help us complete this proposition. Thank you.